Today we're solving problem 26. In this problem we're told that a unit fraction contains 1 in the numerator. We're supposed to find the value of d less than 1000, for which the unit fraction with d in the denominator contains the longest recurring cycle in its decimal fraction part. The way we're going to solve this is by running long division in our code. We're going to iteratively calculate the remainders at every step of long division, and we'll be able to detect if we're in a cycle if we see the same remainder twice. So let's implement this. I'm going to create a method def cycle length denominator int. I totally spelled that wrong. Okay, that's better. And I'm going to create a helper method inside of this, and this is going to be stayed recursive, and I can create a def helper. Now I can import this, and helper is going to be keeping track of two things. One, the list of remainders we've seen before in performing the long division, and two, the current remainder we're at. So I'm going to have remainders of type a sequence of int and current of type int, and this is going to return an int. So the first thing we want to check is, have we already seen this current remainder before? And we can do that super easy with remainders.contains current. So if we have, we want to return the length of the cycle that we found. So that's just going to be the total number of remainders we've seen before, dot size, minus the time that we first saw this current remainder. Because we might run into a case where we have extra digits at the beginning that aren't part of the cycle. So we want to calculate the length from the first digit in that cycle. So I'm going to do minus remainders.index of current. So then we know when this cycle started. Otherwise, what we're going to do is we're going to recursively call helper. We're going to add to remainders the current, because we know that current is not already in remainders. And current is going to be current times 10 mod denominator. And the reason we're doing multiply by 10 is we're just shifting it to the left, as you would do in long division when you're calculating the next remainder. So to use this helper method in cycle length, we're just going to call helper. Our remainders is going to be an empty sequence because we haven't seen anything yet, and current is going to be 1 because we're working with a unit fraction with 1 in the numerator. Now all that's left is calculating our answer, print ln. We're going to go through everything from 1 until 1000 because d is less than 1000. And we're going to get the max by cycle length. And so it's going to use this as its maximization function. We can run, and we get our answer, 983. So that's it for problem number 26. I'll see you next time when we solve problem number 27.